Question 1. Investigate if 4 factorial plus 5 factorial equals 9 factorial. And investigate if 3 factorial multiplied by 4 factorial equals 12 factorial. Well, we know that 4 plus 5 equals 9, but does 4 factorial plus 5 factorial equal 9 factorial? This may not necessarily be true. Likewise, we know that 3 times 4 equals 12, but does 3 factorial multiplied by 4 factorial give us 12 factorial? So let's have a look. So 4 factorial, we know, is 4 times 3 times 2 times 1. So you can either stick 4 and the factorial symbol into your calculator. It's an explanation mark, but in maths we call it factorial, so you can just stick that into your calculator. Or you can input into your calculator 4 times 3 times 2 times 1, because that's what 4 factorial is. And 4 times 3 is 12, 12 times 2 is 24, and 24 times 1 is still 24. So 4 factorial gives us 24, plus 5 factorial. So 5 factorial is 5 times 4 times 3 times 2 times 1, which gives us 120. And 24 plus 120 gives us 144. So we want to see, is that equal to 9 factorial? Well, 9 factorial means 9 times 8 times 7 times 6 times 5 times 4 times 3 times 2 times 1. And to save you putting all of that into the calculator, you can just put in 9 factorial. And that gives us 362,880. And they are clearly not equal to each other. So when we have an equal sign and a dash going through, that means not equal to. So therefore, 4 factorial plus 5 factorial is not equal to 9 factorial. So now let's investigate if 3 factorial multiplied by 4 factorial gives us 12 factorial. So 3 factorial is 3 times 2 times 1. So 3 times 2 is 6, and 6 times 1 is still 6. So that's multiplied by 4 factorial. 4 factorial is 4 times 3 times 2 times 1, which gives us 24. And 6 times 24 is 144. So now let's check if that's equal to 12 factorial. Well, 12 factorial means 12 times 11 times 10 times 9 times 8 times 7 times 6 times 5 times 4 times 3 times 2 times 1, which gives us 479,001,600. And that's clearly not equal to 144. Those two numbers are clearly not equal to each other. Therefore, 3 factorial times 4 factorial is not equal to 12 factorial. Question 2. List all the possible 4-digit numbers that can be made from the digits 1, 2, 3, and 4, using each digit only once to make up your number. Now, this is very, very important. So none of the digits can be repeated. So we're going to have 6 questions all to do with this. So first of all, to list all the possible 4-digit numbers, here they are. And it doesn't matter what order you write them in, so long as you have the same amount. So 1, 2, 3, 4, 1, 2, 4, 3, 1, 3, 2, 4, 1, 3, 4, 2, 1, 4, 2, 3, 1, 4, 3, 2. So they are all the 4-digit codes that start with 1. Next, have a look at the ones that start with 2. So 2134, 2143, 2314, 2341, 2413, and 2431. So they're all the ones that start with 2. Next, we have all the 4-digit codes that start with 3. 3124, 3142, 3214, 3241, 3412, 3421. And lastly, all the 4-digit codes that start with 4. 4123, 4132, 4213, 4231, 4312, and 4321. As I said, it doesn't matter if you wrote them out in a different order, so long as you had the same amount. So let's see how many there were. So for all the ones, we had 1, 2, 3, 4, 5, 6 different numbers we could write out. For all the 2s, we had another 6. For all the 3s, we had another 6. And for all the 4s, we had another 6. So 6 multiplied by 4 altogether is 24 possible outcomes. And a way that we could have come up with this, well, if there was 4 digits to begin with, 4 times 3 times 2 times 1, which is really 4 factorial, that also gives us 24. So if you wanted to just check if you had the right amount, if you were missing any of them, then you should know that you should have 24 in total. So let's say you had been given the digits 1 to 5 and you had to work out how many different possible outcomes there were. Then that would be 5 factorial. If you had been given 3 digits, that would be 3 factorial. So it's a handy way to know if you're missing any. So you're asked to list them. So here they are. There's 24 of them. So now we're going to have a few questions about the different outcomes. So question 1, how many outcomes are there? So we've already covered that. If we count them up, there is 6, 12, 18, 24 in total. And again, remember, we get that by doing 4 factorial. Question 2, how many of these numbers are even? So in order for a number to be even, it doesn't matter how many digits it has. I know all of these numbers here we've listed are 4-digit numbers. So long as the last digit, the digit on the very right-hand side, is an even number. So the first number that's listed there, 1, 2, 3, 4. Well, 4 is the last digit. It's on the very right-hand side, and that's an even number. The next one underneath, 1, 2, 4, 3. Well, the 3 is odd, so that makes the entire number odd, and so on. So I've highlighted in yellow all the even numbers that happen to be at the very end. And I've circled the actual numbers themselves. So how many do we have? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So I've circled 12 numbers. So I've circled 12 even numbers, but remember it's the highlighted part that makes it even. It doesn't matter what all the other numbers are, so long as the last digit in the number is even. That makes the entire number even. Question 3. How many of these numbers are odd? Well, just like the last question, we're focusing in on the last digit. So for this digit here that I've circled, 1, 2, 4, 3, the 3 is the digit on the right-hand side at the very end, and that is an odd number. So likewise, that 3 there is odd, that 3 is odd, that 1 is odd, and so on. So anything that I've circled in red is an odd number. And the reason that they're odd is because it doesn't matter what all the digits in front of the last digit are, so long as the very last digit of a number is odd, the entire number is odd. So we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So there are 12 numbers listed that are odd. Question 4. How many are greater than 3,400? So all of these numbers here start with a 1. So they're 1,000 and something. So they're definitely not going to be counted because they're all less than 3,400. All of these numbers here start with a 2, which means they're all 2,000 and something. So again, we're not going to circle them. These 4 numbers here start with 3, so they're 3,000 and something. But this one here, 3,124. 3,100 is less than 3,400. So 3,400 is what we're interested in. Likewise with the same, 3,142. 3,100 is less than 3,400. Next one, 3,214. Again, that's less than 3,400. And then 3,241, still less than 3,400. Next one, 3,412. Well, that's definitely greater than 3,400. Then 3,421. That is also greater than 3,400. And then all the ones at the end, they all start with a 4, which means they're all 4,000 and something. So these are all definitely greater than 3,400. So there's 1, 2, 3, 4, 5, 6, 7, 8. There are 8 numbers that are greater than 3,400. Question 5. How many are less than 3,400? Well, there's 2 ways of doing it. The quickest way is just to subtract 8 from 24, because we know there's 24 altogether. And in the last question, we said that these 8 are greater than 3,400. So 24 minus 8 leaves us with 16. But another way to do it is just to go through them and check. So all of these start with a 1, which means they're 1,000 and something. They're definitely less than 3,400. All of these ones start with a 2, which means they're 2,000 and something. So they're definitely less than 3,400. And then these ones, well, the first two start with 3 and 1. So they're 3,100 and something. So that's less than 3,400. And these two start with a 3 and a 2. So they're 3,200 and something. So again, they're less than 3,400. And adding them up, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. Again, there's 16 that are less than 3,400. Question 6. How many start with a 4? Well, all of these start with a 4. I've highlighted the 4, and there's 6 of them. So the answer is 6.